So this is an experimental psychology study I'll be describing today. So this is just an outline of the talk. In our lab, we've been doing some work on mind wandering and also on glucose on cognition. And what we've found is that we wanted to sort of link these two areas together and see whether we can extend the findings of the facilitative effect of glucose on external task performance to when we're actually thinking inwards. What does glucose do to the brain actually when we're thinking inwards? So it's a bit of a mishmash of two bits of research we're doing in our lab at the moment. So it's two early studies we've carried out. So if I start off with mind, I'm always like wandering around, but I'm tied to this here. So if I just start off with a traditional view of mind wandering, what we sort of think of when we think of mind wandering is negative impacts. So the negative aspects. So we think of depression, rumination, or in terms of when we're carrying out everyday activities, we think of how mind wandering or daydreaming actually has a negative impact on performance. So that's the traditional view of mind wandering. But if you look in the media, so it's quite a hot topic at the moment, mind wandering, we'll find that not only do we see reports of the negative impacts of daydream, we also find there are positive impacts as well in terms of creativity and the like. So that's another area we're trying to look at within our lab as well. So this is just a bit more of an introduction to the area. So in terms of experimental psychology, what we find, there's one key study out there which actually found that our minds actually drift from the here and now about 50% of the time. So obviously for that reason alone, it's quite an interesting topic to investigate. Now in terms of lab-based tasks, we tend to have two main types of mind wandering. So we have task-related thoughts and task-unrelated thoughts. So task-related thoughts are things like, at the moment I'm worrying whether I'm speaking too quickly or whether I'm too far away from the mic. And then we have task-unrelated thoughts, which are things like, thinking about, after this I'm going to go straight to the bar and have a gin, and that sort of thing. So these are the two broad categories of mind wandering we sort of examine in this sort of work. Now you might ask then, how does this link to glucose? So this is what we're trying to sort of answer with this series of research. So in terms of external task performance, we find that for over 25 years it's been studied, and we see that consuming a glucose-containing drink, typically around 25 grams to 50 milligrams, raises your blood glucose, and as a result gives rise to enhancements in certain cognitive domains. So we want to see whether this will impact on internal thoughts, not just processing the external environment. So I'll quickly go through this, just a bit of background about the glucose and cognition research which is already out there. As people know, glucose is the prime source of fuel of the central nervous system. And because storage is limited within the brain, we need this constant supply. And what you do, if you look in the literature, this glucose facilitation effect, so this enhancement of cognitive performance, is actually found in a number of populations. So in young and old adults, and also clinical populations. So in our lab, we're sort of focusing on the healthy population, mild cognitive impairments, and a bit of dementia work as well. And some more recent research as well, we found that some of the effects we see of glucose on cognition can be mirrored in a diabetic sample as well. So those people who can't efficiently deliver glucose to the brain, we find a similar pattern of results in terms of how this impacts on cognitive performance. And finally, for this background, we find that it's not on everything we find this glucose facilitation. So we give somebody a glucose-containing drink. After about 15 minutes, the blood glucose rises, and it seems to be selective in terms of the enhancements in performance. It tends to be those tasks which have a lot of memory operations or require a large amount of cognitive resources, so the extra fuel is being helpful in that respect. And also more recently, more executive frontal lobe processes tend to be facilitated by this provision of glucose to the brain. And in some ways this links to my thoughts about how the research is going in terms of linking it to the processing of the internal world. So you can think of these executive processes switching between processing of the environment versus inward, and on that basis, that was our start-off point really in terms of whether this sort of switching would be enhanced with glucose as well. So there are questions, because this was the first study, so we didn't have any really strong hypothesis. So I'll let you read through them while I have a bit more of a sip of water. So the main thing we wanted to see was whether glucose was actually facilitate or change the frequency in which our mind wanders to something unrelated to the task or to those things which are related to the task. So that was the first thing. And then what we also wanted to do was actually give sort of a standardized questionnaire and about imagination and mind wandering and daydreaming, and see whether any of these components within the questionnaire also relate to task performance, particularly after being given glucose. And then finally, much like the early work, would giving glucose actually impact on task performance? So here's the methods. So it was a within subject design of 16 adults. They were given either 25 grams of glucose or sweetened matched placebo. We seem to find the optimal dose is around 25 to 50 grams, but it depends on the population, what you're administering it to. Then in the first session, we gave them the short imaginal processing inventory, which has 3 main components. So daydreaming, which can be seen in a positive way, like problem solving, helps generate ideas. And then 2 more negative aspects of daydreaming, guilt and fear of failure, and poor attentional control. So whether when our mind wanders, does this impact on our attentional processing? So this is a very well-known cognitive task which is administered on a computer. It's called the SART task. It's a sustained attention task. What happens is the X's will flash on the screen at regular intervals. So there's loads and loads of these, and every now and again a Y will appear on the screen, so infrequent. And it's your job to actually withhold response to the Y. So you get into an automatic mode of processing when you're pressing the key for the X. And when the Y appears, it's very difficult to actually stop yourself from processing this information. So we gave 2 speeds of this task. So very slowly paced version. Being slow, it gives chance for the mind to wander. And then a faster paced, where possibly you'll be more task focused. And as I've already said, then we measure the 2 components at the end of the task. So the task related and the task unrelated thoughts processing while they were doing the task. So here's the data. So, so as I said, we had 2 speeds of this attention task, slow versus fast, and then we had placebo versus glucose. And what we found is that the manipulation of task difficulty in the cognitive task was successful, in that for the slow task, there was a greater frequency of your mind wandering to something which is not to do with the task, compared to the fast task, where it's just not giving you the opportunities for your mind to wander, maybe because of limited resources. And then what we found, the only thing we found really in terms of a glucose sort of interaction was for the task-related thought. So when the task was particularly hard, there seemed to be more task-related thought, so monitoring of performance. So it may be that glucose in a difficult task doesn't really impact on the frequency of task-unrelated thought, but when there's a need to monitor performance in a more difficult task, this kicks in. So this glucose is giving this fuel to be able to enable you to actually monitor performance. And actually, in terms of accuracy, I mean, they're at ceiling really, because it's quite an easy task. But it was significant in that the fast task, when the monitoring was going on, they were more accurate. Okay. Now this is what we really thought was quite interesting. Still keep moving away from it. These 2 scatter plots. So we've got just for the placebo here, which can be, I guess, considered the control condition. And what we found is that when we measure on the questionnaire, the standardized questionnaire, their attentional control at the beginning of the sessions, we found that that was related to the frequency of task-unrelated thought. So poor attentional control, you're not able to effectively switch between what's important in the environment or what's important internally. So this was related. The same for fear of failure and guilt, so another negative aspect of mind wandering. So again, if you start to worry about task performance and the like, about failing, this was related to more task-unrelated thoughts. But this completely disappeared once we administered glucose. So our argument in the paper was that giving glucose enabled or gave extra fuel to the individual to really buffer these negative thoughts and be able to perform more effectively on the task. So the conclusions from the study, we successfully manipulated the amount of mind wandering by giving the easy versus hard task. So that was quite useful to know that that was the case. When they were given the more demanding task, perhaps the individual needed this extra monitoring, just checking whether they're doing okay while they're doing the task. This frequency of this type of thought was actually enhanced after glucose. And as I've just argued, we feel as if the correlations were actually quite important. So these negative impacts of mind wandering were related to the intake of glucose. So by giving glucose, it did seem to buffer the occurrence of this task-unrelated thought, which again could be seen as a negative impact on performance. And finally, the accuracy, although it was at ceiling, it did show that it sort of replicated earlier study where we find that giving glucose extra resources, you actually perform better on cognitive tasks. So, as I say, it's sort of new, this work for us. So there's just some of the, I just jotted a few ideas down about how we're going to take this further. When we talk about mind wandering, I've sort of divided it into task-unrelated, task-related thought. That is so crude. It's much more than that. So we're trying to sort of get at the content of the mind wandering more, whether it's mind wandering in the future, the past, or it's here and now thinking. So how I've described it today is quite a crude measure. And surprisingly, that's what's been done. But obviously we need to look at it in more detail. I decided to cut this data from the talk. I didn't feel as if I could squeeze it in. But the second study which we've done in this area, we've actually looked at glucose regulation. So we've just measured somebody's blood glucose. I'll give them a glucose tolerance test. And an individual who has poor glucose tolerance actually impacts on the frequency of these thoughts as well. So it's not just the intake of the glucose, it's how you're controlling the glucose. So glucose being important to the brain, it seems to be important for external task performance and also internal thinking as well. I haven't talked about mechanisms. Now we've started some EEG studies as well, and some fMRI. I'm just starting to get my head around all that because it's quite difficult and it's giving me lots of headaches, but that's quite exciting work. So to sort of run alongside these more behavioural work which we're carrying out. And apart from acknowledgements, I think that's it. So that's just the two studies and the people what are involved. Thank you very much.
Any question? Do you know what is more dangerous for our brain? Low level of glucose, and what is the level, or this very big level of glucose, not ketoacidosis? As a neurologist, I just ask. You have to know that. What is the critical level for the glucose in the blood?
So the baseline which we measure is around 4 millimoles per litre.
Less than 4?
So less than 4.
The person can get episeizures and fall down, etc., etc. So our brain working on glucose and plus oxygen. So never mind that a man can and women, people can survive with glucose level 10 milligrams okay, that person needed insulin, but less than 4, especially 3,5 millimoles, our brain can die. So we have to absolutely have that fact on the mind, and in your future overview, I can suggest you to show something more about positron emission tomography PET scan, because in PET scan,
I wish I had access to that,
yes,
but I haven't.
because people got oxygen with positrons, but with the sugar.
I mean, that's a fantastic suggestion, you know, if I had the resources.
Yes, oxygen 15, that is positron, and the people get glucose, and then we can imagine in 3D or 4D the brain functioning during tasks. Wisconsin, if you are a neuropsychologist.
Well, if you've got a scanner, maybe I could borrow your scanner.
Okay. Okay, thank you very much.
Thank you.
Lady from Hungary, it's Andrea Kovesdi, and I pronounce okay. Investigation about resilience. Scusi. Sorry.
Hello everyone, dear colleagues. I'm Athena Vakaliosz from Hungary, and my topic is investigation of resilience in adolescent girls with anorexia nervosa. First, I would like to present the theoretical background. Resilience was first studied in this Kauai longitudinal research, and they found that the ability of resilience can change in lifetime, so even in adulthood. As the present definition says, resilience is a dynamic process of the internal and external risk, as well as protective factors which affect the flow of life of the person. And it's important that this does not mean an invulnerability, rather an ability to recover. So, resilient people are able to cope with this stress successfully. Future research among adolescents examined 2 factors, psychosocial factors and protective factors, and most of the research focused on emotional well-being. As the process-based approaches define resilience, is an interaction between risk factors and protective factors, and this means some kind of balance of the adolescent, the family environment, and the community. And we highlighted adolescent because in our research we examined the personal factor and not the environmental one. As research says, optimism is a predisposing protective personality factor compared to avoidance behavior which predisposes for aggression and depression. Optimistic people tend to use approach coping strategies. What is more, optimism is even more protective if it's a dispositional aspect of the personality. Let's move on to our own research. You can see our sample here. We examined 55 adolescents, 28 with anorexia nervosa and 27 controls. You can see that the BMI was quite low in the anorexic group, so they are quite serious patients. The investigation took place at Semmelweis University, #1 Clinic of Pediatrics, Department of Child and Adolescent Psychiatry in Budapest, where we work, and in 4 high schools. And you can see our instruments here. Those which are highlighted, we use the results in this presentation. You can see our hypothesis here. #1, the anorexic sample is less resilient than the control group. Participants with high depression score are less resilient. #3, participants with high anxiety score are less resilient. #4, participants with high emotional richness are more resilient. And #5, participants with high score in optimism are more resilient. As our first result, you can see the correlation between the BMI and resilience, and the red spots are the anorexic group, and the blue one are the controls. And as a surprising result, a lot of the anorexic patients showed a very high resilience score. So we started to think about that, how can that be? And first we marked them with this green sign. And after we examined the correlation between optimism and resilience, And as another surprise, we found that in the optimism scale, they also score quite high results. And that's where we started to think that something must be wrong. That's why we regarded this social desirability scale of the SAFA scale. And we found that they score quite low in this social desirability. And we also followed up these patients up to 1 year. And in the therapy, we found that they were resistant. So in the end, we excluded 5 patients because of these reasons. You can see our modified sample here. And on this sample, we found a significant difference between the anorexic group and this one is the anorexic and the control group. After that, we examined the correlations between the BMI and resilience. And as you can see, although in the whole sample, there was a significant correlation between the BMI and the resilience, but in the anorexia group and in the control group, there was no significant correlation. So it seemed that it's not the BMI that affects the resilience. So we continued with examining the correlations between resilience and depression, anxiety, and eating. These are the scales of the SAFA scale. And we found that depression and anxiety were both correlated with resilience in all groups, so in the whole sample, the anorexic and the control group. But the eating scale only correlated in the whole sample and in the anorexic sample with resilience, not in the control group. Here you can see the graphic interpretations. As you can see on the first figure, it's the correlation between depression and resilience. On the second, the anxiety with resilience. And as you can see on the first 2 figures, the points are organized along a straight line. But on the third one, where the eating correlation with resilience is shown, the points are quite randomly scattered. We continued with regression analysis to determine which of these 3 factors are the most powerful. And on the whole sample, we found that 43.6% could be explained by these 3 factors. And depression was the most powerful factor that determined resilience. We continued by examining the subscales of depression. And we found that except irritability, all of the subscales showed correlation with resilience. We also examined these subscales. So in this figure, you can see the connection between the subscales, and we tried to find which of these are the most independent ones. And we found sense of insecurity, remorse as feeling of guilt, and hopelessness as the most independent factors. So we continued to examine these factors. We also used regression analysis, and we found that all of these correlated significantly with resilience. But after partial correlation between feeling of guilt and resilience, when controlled for sense of insecurity and hopelessness, this significant correlation stayed, but the value turned to be positive. So there was a change in this value. And that's when we started to think what exactly can remain of this feeling of guilt if we take out the negative feelings, so hopelessness and sense of insecurity. And first we saw that it can be conscientiousness, which can be measured by this NEO-PIR questionnaire, but we didn't find any significant correlation. Our next thought was emotional richness. That can also be measured by this NEO-PIR questionnaire. The feeling, openness to feelings subscale represents that. And there we found significant correlation. That's why we continued. We split this openness to feelings factor to 2 subdivisions, feeling awareness and feeling intensity. And with partial correlation between feeling of guilt and feeling awareness, when controlled for these above, we found a significant correlation, and with partial in the whole sample, and also in the partial correlation between feeling of guilt and feeling intensity, we also found on the whole sample significant correlation. But when we checked it for the control group, we only found a significant correlation on the feeling intensity with feeling of guilt, but in the anorexia group on both feeling intensity and feeling awareness. On this figure, we represent that how emotional richness and resilience is connected. So the feelings are represented, and from left to right there are from negative to positive feelings. From the bottom to the top, the feeling intensity is higher, and the obscurity represents the feeling awareness. And as a conclusion, we can say that those who are able to feel their positive emotions intensely, those are prone to resilience, these people. We continued by examining the correlation of resilience with depression, anxiety, and eating, but in the anorexia group. And in this group, our results were that the eating subscale was the most important factor that determined resilience, which is quite an interesting result, that in the whole group it was depression, and in this anorexia group it's the eating subscale. We also examined the subscales of eating, and we found that anorexia, acceptance of body, and fear of growing up showed significant correlation with resilience. These are the characteristics of anorexia. And at the end, we examined the correlation between optimism and resilience, and we found that in all samples there was a positive, significant correlation between optimism and resilience. So according to our results, our hypotheses were all verified. So you can read them here, if I can. Oh, yeah. Okay. We also found that the correlation between feeling intensity and resilience is modulated by the balance of the dominant emotions. And as a discussion, I would like to highlight some of our findings. So first, that depression was the most important factor in the whole sample that explained resilience, but in the anorexia group it was the eating subscale, and also that feeling awareness and resilience showed significant positive correlation in the anorexia group, but feeling intensity and resilience showed only significant positive correlation in both groups. It's important that these factors can influence therapeutic interventions by strengthening the protective factors. Our further plan is to analyze the eating subscale in the anorexia group to find out how depression loses its main explanatory role in the whole sample against the eating in the anorexic sample. Thank you for your attention. Eating is a subscale in the SAFA scale, so it means both the eating behavior and the thinking about eating. So the anorexic thoughts are included in this eating subscale. So it means that. So it's eating avoidance. Yeah, and the way of thinking, the anorexic way of thinking is included in this scale. So those who are more thinking as an anorexic patient, it's less resilient in the end.
Okay, thank you.